course is on Python data visualization. So data visualization helps people make decisions faster by presenting complex data in an easy to understand way. It also improves retention by enabling the brain to process visual information more efficiently than the raw data alone. Python libraries like Matplotlib, Seaborn, and Plotly make the process smoother, offering a wide range of customization options for various needs. Now, why is visualization important? It first of all, it speeds up data interpretation. Rather than sifting through tables of numbers, people can spot trends, correlations, and outliers at a glance. And it also enhances communication. So whether in meetings, reports, or presentations, visuals communicate complex information clearly, making it more accessible. And also it improves decision making. Now, businesses and researchers use visualizations to drive insights that influence strategy, development, and problem solving. Now, Python offers a variety of libraries to suit different visualization needs, and each has its strengths depending on the project's goals. So, the most common one is Matplotlib. That's the most fundamental library. It provides a solid base for creating static charts like line, bar, scatter plots. It allows fine control over every element of the plot, making it highly customizable but requires more effort for complex visuals. And then another one is Seaborn. Built on top of Matplotlib, Seaborn is tailored for statistical graphics. It simplifies the creation of advanced plots such as heat maps, violin plots, and pair plots, which offering better aesthetics with fewer lines of code. And another one is Plotly. This is ideal for web applications and interactive dashboards. Plotly enables the creation of dynamic interactive plots like 3D charts and maps. It's useful for sharing visuals online as users can zoom in, hover for details, and interact with the data. We will mostly be focused on Matplotlib and Seaborn. Plotly is a little bit advanced. Um, okay, so now before we start coding, we're going to have to install some libraries. We will be using Matplotlib and Seaborn. And also, after we install them, we would have to import them to be able to use them during coding. Now, I have already installed them globally. And I'm using VS Code for my code editor, but any other code editor can be used. For example, I believe Jupyter is very popular for data analysis, but I'm comfortable using VS Code, and this can be used as well. So in order to first install it, you would have to go to terminal, new terminal, and then just type here pip install matplotlib Seaborn. So because I have already installed it, it won't actually do anything because like it says requirement already satisfied. So I won't have to go through this again. I can just start coding. So I'll just create an example file, say py, and then I'll just type in the code. So the first code, we are going to create a line plot. For that, first I import the Matplotlib library. It's just giving me suggestions, so it's much easier that way. I plot as PLT. And then I'm going to create two lists, X and Y. So these are going to be used to represent like the data points for the plot. So I'm just going to type in regular, like just random numbers, maybe 1, 2, 3, 4, 5 for X. And then I'm going to type in Y, just going to be 2, 4 and 10. All right. Okay. Now we will type plt, which is the matplotlib library that we just imported, dot plot. Now what this does is that the x and y inside. So what this does is that it is the function that actually creates the line plot by connecting the points in x and y. And then the next line that we're going to type is plt.title, and I will type line plot example. Now this line will just create the title for the line plot, and then we will create a label for x-axis and y-axis, which is going to be x label. It's going to say x-axis. And I'll just change it to y label for the y-axis. And then lastly, we will type plt.show. So even though we create the plot using all these lines, it won't show unless we write this line of code. Okay, so once we're done, I'll just Control S to save it, and then I can run it. Hopefully it shows you, there you go. So this is the visual, the plot that we just created. So in here you can try changing, like zooming in if you want, like this. You can reset it by clicking on home. You can go back to the previous view. You can also drag it. There are some options, some more options that you get in here just to change the way it looks, but I'll just reset it to how it was. You can also save this for later use. So if you click on save option, you can save it wherever you want, give it a name, and it will be there. And once you close it, that's when you will exit out of the program. Okay. So this was the program that we just wrote. Now this is the second example where we create a bar chart. So for this one, I am going to be using Pandas and read data from an existing Excel file, and then I'm going to turn it into a bar chart. So first, we would need to install Pandas and open PyXL. So OpenPixel is what lets Pandas read Excel files in the XLSX format. Now the code starts by importing Pandas and Matplotlib, and and after that, you would have to make sure that the Excel file is in the same folder as your code. So if it's on a separate folder, it won't be able to access it. Now, next, the line that says pd.read_Excel, and inside the brackets, inside the parentheses, it says your file.xlsx. That is the file that you will be using. So the name of my file is just your file.xlsx, but you can replace it with the name of your file. And this just reads the data, the Excel file, and then it stores it in the data frame, which is like the data variable right here, which will look like a table. And then we take out two columns from the table, one for the categories and one for the values, which is what my table is. And then you can replace them based on what your table looks like. And then the next line, which says plt.bar, and then inside the brackets it says categories, values, color. So because my Excel file only has two columns, categories and values, I place them here, and then I want the color of the bars to be sky blue. And then title is for title, and show is for showing the the bar chart. So if I go back there, again, I already have those installed. So I'll just change this code and I will type a second. Map dot. Oh, sorry, my bad. Import pandas because I'm gonna read a file. Pandas as PD, and then I'm gonna import matplotlib here dot pyplot as reality. And then I will I'll type data is to ed dot read underscore excel here. So copy your file. And then I'll type categories for data. And then values for the values. Okay. And now I will do a pld dot bar, which is basically creating the bar chart. We'll have categories, values, color will be sky blue. And then just create the title. And lastly, I will do pld.show. Okay. Now I'm gonna run it. If I have the file in the same location, it should run without any errors. But like you can see right here, it says no such file or directory because this file is not in the same folder as I have this code in. So I will just copy this file. Oh. And that's where my example is. Okay, so I'm gonna run the same code again. I'll just delete this. There you go. So this is the bar chart. So I created it using this data right here. So it read this data and then it ran the code. And then it created the chart, which is this. It has the title, and then the categories and the values. Okay, so next we're going to talk about scatterplot. So I'm gonna be creating a scatter plot using my Pandas and Matplotlib. So we start by importing Pandas and Matplotlib again. Pandas is used to read the Excel file and Matplotlib is for plotting. So again, I'm using the same file. It's gonna load the Excel file into the data frame. Just gonna be called data right here. And then after that, we have the columns, category, and then the other column is values, and then the line plt.scatter is what will create the scatter plot. So x, y is for x axis and y axis, and then we have the color green. So for scatter those dots, I am using the color green. It will create the scatter plot. And after that, we just give it a title and also the line plt.xticks rotation 45 that will rotate the labels on the x-axis so that they don't overlap. However, in my file that I'll be using, it doesn't have, like, the names are not too long, so I shouldn't be needing that. And then finally, plt.show will display the data. So let's see how it looks like with this Excel file. So it's just, the first two lines are going to be the same. I am going to do actually yeah, this line is also going to be the same. Right. So I'll have the X for data category and then Y for data valid. And then pld.scatter, which is the function that creates the method that creates the scatter plot, x and then y for x and y axis values, and then color is going to be green, so I'll choose green, and then I will use create a title, which is called scatter plot example. And I will also create some labels, just pld dot x label. For that, it will be a category and then the y label, which is a value. I won't be rotating the labels. I'll just run this and see how it looks. Okay. Yeah, as you can see, the labels in here are not very long, so I didn't have to rotate them. But for example, here they were like long names, so I had to rotate them a little bit. Okay. Okay, now we're gonna work on a histogram. So I will be showing how to create a histogram using Pandas and Matplotlib again. So a histogram is a type of chart that shows the distribution of data. It groups values into ranges called bins and then shows how many values fall into each range. So we start by reading the Excel file into a data frame with Pandas. For histograms, we use the column called value and then the line plt.hist data value bins equals to 10 and color orange and edge color black. That is what creates the histogram. So the parameter bins equals to 10 means the data is divided into 10 ranges, and the bars are colored orange and outlined in black to make them clear, as you can see here. We also add a title, label the x-axis as values and the y-axis as frequency, which shows how many values fall into each range. And then pld.show, as usual, shows the histogram. Okay. The first few lines are the same. Let's up to here. So I'm gonna remove these uh, these few lines. Okay. So we're gonna write the code for creating the histogram, which is this, and then fill out the information inside. The arguments are gonna be value, and then bins are gonna be, it's gonna be 10. Next color is gonna be orange, and edge color is gonna be black. And for title, instead of saying scatterplot, I'm just gonna call it histogram example. And for X label, I will change this to value. Then let's change this to frequency. Okay, let's see what it looks like. Right, so there you go. It has the histogram here. Here's the frequency, value, and yeah, you can save it as usual. Right, so there's another example, where I create a histogram using NumPy. Instead of reading data from a file, I just create like a variable and I store like random numbers in it, and then I create a histogram using bins, which is 20 this time, a different color, and alpha means transparency, how transparent it's going to be. And then I name it as histogram example as usual, and then show will show the histogram. Okay, so okay, so here are some customization options in Matplotlib. The ones that I used are like the very basic ones that you can use to determine how your charts or your histograms or scatter plots are going to look. But here are some more. For example, in line plot, line style equals to dash makes the line dashed marker or adds circular markers at each point, and color purple just changes the color of the line. And then for scatter plots, S equals to 100 controls the marker size. Alpha zero point 0.7 makes the points partly transparent, and marker equals to that upper arrow thingy that changes the marker shape to a triangle. In bar chart, each color equals to black adds a black border around each bar, and also width equals to 0.6 changes how thick the bars are. And in histogram, bins 5 controls how many ranges the data is grouped into. Alpha equals to 0.8 again adjusts transparency. His type bar just lets you choose the style of the bar. You can choose anything else like step filled. And orientation vertical means the bars go up and down. Okay, so now we're going to talk about Seaborn. Seaborn is a library built on top of Matplotlib that makes plots look nicer and is very useful for statistical visualization. In the first example, we load a built-in dataset called tips using sns.load underscore dataset tips. So Seaborn, Matplotlib, they have like built-in datasets which you can use, and I would suggest when you're first starting out, you can just use those. They're very big, and the bigger the dataset, the better your charts are gonna look. So you can just load them and then use them. So this dataset that I'm using contains information about restaurant tips such as the total bill, tip amount, day, time, and so on. And the command df.head right here, it shows the first few rows of the dataset. So let's go back. I'll remove all this and I will import Seaborn as SNS, and then I will load the load the dataset here, just SNS dot load load dataset, and I'm gonna type in the name that I'm using, the name of the dataset that I'll be loading, and then df head. This just selects the first few rows, and then in order for it to show, I'm gonna have to print it, otherwise it won't show up. Or you can just do it in one line and just add print statement there instead. Um, okay, so if I run it, in here you can see it's showing first 5 rows of this dataset. It has IDs, it has total bill column, or column for tips, and then male or female, whether they're smoker or not, which day, what time, and then size. So it's much bigger than this, but it's only selecting the first 5 rows. But this is what the dataset that looks like, and this is the dataset that we will be working on from now. Okay. Now this is another example with the same dataset. We will be creating a histogram, and we will be doing using a KDE, like creating a histogram with KDE. Now in here, the function SNS, I'll just make it bigger so that it's easier to see. Yeah. So sns.histplot.df total bill KDE true color blue. So this line creates a histogram of total bill columns. So I think the first or the second column. The option KDE means equals to true means it's gonna add a smooth curve on top called a kernel density. As you can see, there's like a blue line that goes across all the bars from the top. So that's what it's doing. And this just shows the overall distribution shape more clearly. We also add a title and access labels, and finally call PLT show to display it. Okay, let's see what it has here. Again, I will have to import Matplotlib. Good. And now I'm gonna load the dataset, which is it's already loaded, so we won't have to do that again. Okay. Now I'm gonna create the histogram. Just hist df for the dataset that we selected. Total bills is the column that we are working with. And then KDE for the kernel density line, we're going to set it to true. And then we're going to change the color to blue. Okay. And then again, we will type in a title, which is histogram and we'll create some X and Y labels. And lastly, we will have to make sure it shows us whatever it created. I'll remove this line, save it, and let's see. Okay, there you go. So this is the histogram with the kernel density estimation, that line right here, and yeah, it has the frequency right here, total bill along the x-axis. Okay, so the next thing that we are going to do is we'll create a scatter plot using the same data set. So we're going to use Seaborn again, and it just makes the scatter plot look much nicer, as you can see here. So rather than regular Matplotlib, and this kind of scatter plot can be used for comparing two types of variables. So we start by loading the tips dataset again, and then after that, we create the scatter plot using the lines sns.scatterplot x equals to total bill, y equals to tip, data is equal to df, which is the tips dataset that we just loaded, and then hue is equal to sex, and then style is equal to sex, and then s equals to 100. So this creates a scatter plot where x-axis is total bill and y-axis is the tip amount. The option hue, that is the color that sets the color, the points by the sex of the customer, and the style changes the marker shape for each category. And s equals to 100 just makes the markers bigger so that they're easier to see. And then we just add a title, a label, axis, and then finally show it. So we will start from this line, line 6, because the first three lines are the same. So we will say scatter plot. Give it some space. Okay. Scatter plot, and then x equals to total bill. Then y will be equal to tip. Then data is equal to df. Then we type the hue just based on the category with sex, and then same for style, and then type as equals to 100. Okay. And as for the title, we just change the name, which is going to be a just scatter plot. And for label, total bill is fine. Y, for the Y label, we can just change it to tip. Okay. There we go. The same scatter plot generated here. The blue dots are all males, and the orange, the crosses are all females. And yeah, the tip amount and total bill. Okay, so next, a box plot. So box plot is a type of chart that shows the distribution of data, including the median, quartiles, and possible outliers. It is useful for seeing how data is spread and comparing groups. So in this example, we're using Seaborn again to create a box plot. We load the tips dataset, and then the line sns.boxplot x equals to day, y equals to total bill, data, and palette equals to S2 creates the box plot. So x-axis shows the day of the week, and y-axis shows the total bill. And the palette S2, it's just the option that sets different colors for each box to make the chart easier to read. And then just as usual, add title, axis labels, and then display the box. So we go back. We're just going to change this line first, which is going to be box plot, and we'll fill out the information inside. It's going to be total bill, and make sure you're writing the column names match with the dataset that you're working. Data will be df, and then palette will be set to, and then I'll just change this to box plot. And now for this one, the X label will be the day of the week, and Y label will be total bill. So I'll just cut and paste it here instead. And this is going to be the day of the week. Right. So there you go. Okay, now heat map. So a heat map is the type of chart that shows values in a table as colors. It is useful for visualizing patterns, trends, or correlations between variables. So in this example, we use Seaborn to create a heat map. As usual, we load the dataset, and then the line core CORR equals to TF CORR bracket numeric only equals to true. Calculates the correlation matrix for the numeric columns. This shows how strongly each pair of numeric variables is related. The line sns.heatmap CORR anode true CMap coolworm creates the heat map. The anode equals to true option adds the correlation values on the chart, and CMap equals to coolworm sets the color scheme from cool, which is the low values, to warm, which is the high values. And then finally you set the title, and then just show the display the heat map. Again, we go back. So most of these examples have very similar code. Just changing like a few lines of code just creates a different result. So again, I'll just add an extra line here for the correlation, which is going to be df, and then I'll choose numeric only and set it to true. Oh, true. And after that, I'll just change this. And I'll just to true. CMap will be full worm. And then I change the title to heat map. And we won't be needing the labels for this one. Okay, here's the heat map. Okay, so the next example is of a pair plot. I believe this is our last code example. So a pair plot is a chart that shows scatter plots for every pair of numeric values in a dataset. It helps you see how variables relate to each other and also shows the distribution of each variable along the diagonal. So this is useful when you want to understand patterns or trends in your data before doing more advanced analysis. So as you can see, it just compares the data. For example, the total bill, the first column here is total bills, and then the top row is the left, top left corner is the total bill. Uh, that being compared to, for example, tip is right below here, and then size is at the very below at the bottom left corner. So it just compares each numeric column to another and creates the pair plot. So again, we're gonna load the dataset and then sns.pairplotdf automatically selects all the numeric columns like total bill, tip, size, and creates scatter plots for each pair. For example, you can see how total bill and tips here are related. And then the diagonal shows the histogram of each numeric column. So you can see the distribution of values. So, and then the line plt dot subtitle pair plot example y equals to 1, that just adds the title above the plot and plt show displays the pair plot on screen. Okay, so we go back. We're just gonna get rid of this line and just gonna change this and type in pair plot. Yes. And then add another line that says ld.subtitle, which adds the title, which is pair plot. And also I'm gonna set y equals to 1. Okay, and we don't need the title, this line right here. It's very short. As you can see, we just created the pair plot for us. Okay, so the best practices for visualization would there are like a number of things that you can follow. For example, you have to choose the right chart type for your data. So, for example, use bar for categories, line for trends, and then label the axis and titles clearly so that it's understandable what those are. And then also keep the plots simple. If just try to avoid clutter so that it's easy to understand, and also choose colors wisely so that they're readable and have like a good contrast. And if you need, then you can add legends. So there are some hands-on exercises that you can try. For example, you can create a line plot showing monthly sales numbers. You can also use Seaborn to make a box plot of total bills by day from the tips dataset and create a heat map showing the correlations. Right, so Python does provide libraries for visualization, which makes our life so much easier. Matplotlib is the foundational. Seaborn is better for statistical plots and just makes it look much better. Plotly is a bit for a bit more advanced level. It it lets you interact with the charts and um, Other than just practicing these examples, if you want to just dig deeper, you can just go to the official documentations, read through them. It may look a bit daunting at first because it is a lot of information, but as you just read along, learn, you will start to understand. Plus, by reading documentation, you can learn a lot. So that is a good practice. So you can just go to do that through these links. All right. So, any questions?